Hi everyone, I'm Vanji from California and I work as a solution engineer with WSO2. It is an open source integration company. During my free time, I volunteer with Apache Synapse project as a project committee member and a committer. This talk mainly going to cover API management and how API management play crucial role to enforce the quality of services on top of serverless functions. So as a very first step, let's quickly review what is an API. An API are the digital asset and contract between developers on how, when to interact to obtain the data or push the data into ecosystem. Having said that, now API is also recognized as a product of the 21st century in the digital transformation era. Since most of us already familiar with these concepts, I like to move on to other topics. Like how the most of the APIs are deployed. Mostly there are three different approaches taken by most of the organization right now. So they are like deploying API in bare metal or virtual machines or containers. This infrastructure may be owned or rented by on demand by the organizations. However, as most of us know, the cost and complexity of infrastructure does not come alone, but also come with other critical challenges that can impact return on investment, like managing the servers, operating the servers, securing the servers, time to market to take your product, or sale of the services, or the cost of the idle time. So, and I can keep on telling about these and so on. So one of the potential solution to overcome this problem is serverless functions. So what is that all about? Serverless is about the ability to run the service without allocating servers permanently. And resources are dynamically allocated when the requests are made. Further, these invocations are very short-lived and the best match for the serverless and stateless processing. Further, this also enables developers to focus on more on code and less on infrastructure. Currently in the market, there are many vendors providing these serverless functions, and I have listed few over here. For our discussion purposes going forward, I will take AWS, Azure, and IBM offerings in my later stage of my presentation. But for right now, I'm not going to get into the more details, but let's move on and talk about the API management. So API management, as the term sound, API management is a software ecosystem that allow to publish API for cataloging, enforcing the user policies, controlling the access of the API, nurturing the subscriber community like forum, documentation, and so on. Further, collecting the metrics and analyzing the usage statistic also help the API provider to understand about what can be improved in API ecosystem. Further, reporting on the performance, maintaining of the life cycle of the API, and monetization of the API, and I can go on. But it has three main core functionalities to maintain all these API management ecosystem. So first of all, to enforce the security, there is a component that it belongs to, and govern the artifacts that we are enlisting in the API management. There is a main need of that, and proxying the runtime is also another core part of the API management. However, when we getting into much more deeper dive into this system, we can also look into these facts much more deeper. I have listed some functionalities, but for our discussion purposes, I have to break these into three main features, but that's what we discussed previously. But if you ask me to pick a few of the main features that I would consider to talk further, I will choose 6 main features, and they are implementing the security around the API, cataloging the API, API observability, monetization of the API, rate limiting of the API, and control the access with the marketplace for the API. Putting all of these into one big picture and summarizing will illustrate there will be a gateway acting as a central place to route the traffic and other components to provide the necessary management plane activities. But as you see in illustration, the gateway receive the most of the runtime requests to do the necessary orchestration and apply the quality of services that we have already defined for that API using the publisher. And when we expose the API through API management, it's well known as the managed API. So as you see in this picture, we do have multiple different components that acting together to enforce these quality of services. So one of that is the publisher and then developer portal. The publisher is nothing but a portal that allow the API developers to come and enlist their APIs to the wider community to access it. And the app developers and API consumers usually come to a developer portal or marketplace and discover those API and get the subscription from them. Then from there on, any API consumption goes through like gateway, and gateway do the rest of the orchestration using with the key management to validate the keys and talk with the traffic manager to enforce the traffic management policies and collect the real-time data so that it can make the providers can make a better decisions. But importantly, as you see over here, there are a few other main elements in this picture, like microservices, web services, and enterprise service bus are running behind the scene to expose the necessary business functionalities. But our focus here is mainly serverless functionalities, so I'm going to move on to that. So most of the serverless function provided also a gateway functionalities. However, it is not fulfilling the enterprise need. Most of the enterprises with a different business unit may or may not use the different infrastructures as a service vendors. For example, one business unit can use the AWS and other business unit may use the Azure. However, there might be a need of aggregated API platform to expose these APIs and functionalities to their internal or external consumers of these API. Therefore, there is a need of managing the portfolio of the serverless functions from the different platform in a single management ecosystem to allow the organization to enforce the unified quality of services across the platform. Looking into this and mapping this concept with the previously illustrated image of API management, it simply expose the serverless function via the common gateway and enforce the quality of services like rest of the managed API. So this provide many benefits, including a single marketplace to enlist the serverless functions, and also provide a single identity provider so that all the identity can be managed in single platform. And further, it also can be rate limited, in one single platform. So as you see over here, I have depicted a few of the serverless function providers like AWS Lambda, Azure, or IBM. However, moving forward, there are a few other benefits of this adapting the API management platform as well. One of the benefit that I see right now So if there is a API already available that running on top of the, let's say, bare metal and it's written in Java, and if the organization choose to migrate to the serverless function, right now let's discuss that the API is simply exposing a get method. When the payment API with the latest resource invoked by client, it simply returning back a JSON payload. And when we want to migrate this into a serverless functions, so the same similar implementation can be written as a function in any of the serverless function vendors. For example, let's take AWS Lambda. And in this case, I have written very simple Lambda function to handle this invocation. As I illustrated in the previous one, the simple JSON payload has been written over here. But as you see on your left-hand side, the response is coming back from the serverless function is a very simple string rather than the well-implemented payload. So this can be one of the disadvantage or the complexity that you can find during the migrations of serverless functionality. And this is also mean the contract between API consumers and the API providers is being broken, and implementing the API consumer app will be very costly and time taking. So to the go to market will be delayed, and there can be many other implications as well. To solve this, there is, there is an option that what we can do. We can utilize the API management ecosystem to do the necessary message transformation and do the rather than completely rewriting the entire implementation for the both API providers and consumers. So most of the modern API management ecosystem come with implementation where it allow you to do the necessary message transformations or header transformation or do the necessary orchestration inbuilt within the gateway itself. So as you see over here, the API management is acting as a proxy in between the client and the payment API and doing the necessary transformation rather than just sitting in between and enforcing the quality of services. Further, there is another good advantage that we can talk about here is most of the serverless functionalities, as we discussed previously, can allocate the resources on demand and execute on demand. So this may cause some delays during the first few request response, and this gap can be closed by API management. And API manager can act as a cache provider for given request signature. So I do have a quick demonstration over here I'd like to present to you guys. So in this demonstration, what I'm going to do is I'm going to utilize two different products over here. One is AWS Lambda serverless functionality. At the same time, I also will be using the WSO2's API manager to expose this API as a serverless function. So as a very first step, I will get into the Lambda function. I have already written very simple API using Python, and it is a serverless function that right now running. Very simple message and returning back status code as a 200 when this been invoked. Then also I do have my local deployment of WSO2's API manager, and I will be creating a very simple API over here. Let me name it as a payment API, payments API. So provide the version as 1.1. As of now, let me skip the endpoint and choose the business plans for the API consumer so that they can choose from it. As an API provider, I can define these. And I'm creating this API. And as you see, the life cycle of this is still in the creation state, not in the published state. So as a very couple of steps, what I'm going to do, I'm going to integrate with the AWS Lambda so that I can right away access the functions that I have been created already. So since this is running on my local machine, I don't have the IAM of AWS, and I cannot access the AWS credentials to this. So if you're deploying this in the AWS instance itself, it will pick up and use the AWS credentials to do the necessary interactions. So that what I have done, I have already downloaded my keys from AWS. So I'm going to provide those over here. And I'm going to choose the region that I'm in right now, US West, like California. US, yeah, this is the one. I'm going to save it. So as you see, I have added the necessary integration between AWS Lambda over here, but I haven't added any resources for that. So let me do that. Let me remove the unwanted APIs over here. Let me save that. And I'm going to choose my functionalities over here. I already know the ARN. Since the integration is there, the ARN will be pop up over here. And I have choose this. So as I inform already, right? So you can do other quality of services, but considering the time right now, I'm going to skip those activities. I'm going to deploy this. So since I have added the necessary the resources, functions, and API details, now I can go ahead and publish this API. So what I'm going to do, since all the checkpoint is done, let me publish this API, and it is ready to consume. So let me check this out in my developer portal or the marketplace. It's appearing there. So let me choose my credentials over here. And I'm going to add a new application. It's nothing but collections of API to manage the keys and everything in the right manner. So I have created the application. I'm going to generate a few keys so that I can access the security and enforce the security over here. I'm copying that. What I'm going to do, since I already have access, I haven't subscribed, I'm going to go ahead and subscribe to that application, which is serverless-based applications with a gold plan, and I'm subscribing to them. But what I'm going to do now, since I have a new subscription, let me quickly regenerate the key. I don't need any scope right now. I'm getting back to the API payments. And I have done the necessary subscription so that I can try out this API. So this API is going to act as a very simple REST API, but underneath the implementation is the serverless functions that we have implemented in the Lambda. So what I'm going to do, I'm going to provide the key that I already got. I'm going to try this out. So as you see over here, the response is coming back from the backend. So as a API provider, what could have done is I have engaged over here and added the other quality of services. For example, over here, the message mediation, nothing other than, I mean, very simple, what do you call, mediation policies or the orchestration policies that I could have added over here. And during the request response, this will be engaged, and the message could be transformed as we discussed previously. Is there any questions so that I can answer and help you to understand this further? Thank you.